must have seen the local municipality workers doing the fumigation of your society and the surroundings. I think most of you might even know the name of the chemical used for this process. It is known as DDT. Its full form is dichloro-diphenyl trichloroethane. Now, this common chemical used for the process is haloarene. Let us quickly revise haloalkanes and haloarenes. Here, the replacement of the hydrogen atom or atoms in an aliphatic or aromatic hydrocarbon by halogen atoms leads to the formation of the alkyl halides called as haloalkane and aryl halide called haloarene. Let us now start with the classification of haloalkanes and haloarenes. We will classify them based on the number of halogen atoms. They are classified as mono, di or polyhalogen compounds depending on the number of halogen atoms in their structure. Monohalogen compound have one halogen atom in their structure. Dihalogen compound has two halogen atoms and poly means more than two halogen atoms in the structure. The screen shows mono, di and trihaloalkane and haloarene compounds. Now, let us discuss the further classification of mono-halo compounds according to the hybridization of the carbon atom to which the halogen is bonded, that is the sp3-CX bond. The first classification is alkyl halide or haloalkanes. Here, the halogen atom is bonded to an alkyl group. They form a homologous series represented by the general formula CnH2n+1x or Rx, where R is alkyl group and X is halogen atom. They are further classified into primary, secondary and tertiary depending upon the nature of carbon to which the halogen is attached. The first one is primary alkyl halide. If the halogen is attached to a primary carbon atom, then it is called primary alkyl halide. The second one is secondary alkyl halide. If the halogen is attached to the secondary carbon atom, then it is called secondary alkyl halide. And the last one is the tertiary alkyl halide. If the halogen is attached to a tertiary carbon atom, it is called tertiary alkyl halide. The second classification is allylic halides. These are the compounds in which the halogen atom is bonded to an sp3 hybridized carbon atom which is adjacent to a carbon-carbon double bond, that is allylic carbon. For simplicity, we can say that the compounds in which the halogen atom is bonded to the allylic carbon are known as allylic halides. The third classification is the benzylic halides. These are the compounds in which the halogen atom is bonded to an sp3 hybridized carbon atom attached to an aromatic ring. The next classification of the mono-halo compounds is according to the sp2-CX bond. The first one is vinylic halides. These are the compounds in which the halogen atom is bonded to an sp2 hybridized carbon atom of a carbon-carbon double bond. The second one is aryl halides. These are the compounds in which the halogen atom is directly bonded with the sp2 hybridized carbon atom of an aromatic ring. Having done the classification of the halogenated compounds, let us now move on to the naming of these compounds. The alkyl halides are named as halo substituted by hydrocarbons in the IUPAC system. For monohalogen substituted derivatives of benzene, the common and the IUPAC names are the same, but for dihalogen derivatives, the prefixes ortho, meta and para are used in the common system, and in IUPAC, the numerals 1, 2, 1, 3 and 1, 4 are used. The dihaloalkenes having the same type of halogen atoms are known as alkylidene or alkaline dihalides. The dihalo compounds having two halogen atoms are of two types, gem dihalides and wick dihalides. Gem dihalides have both halogen atoms present on the same carbon atom of the chain. These are named alkylidene halides in the common system. Wick dihalides have halogen atoms present on the adjacent carbon atoms. These are named as alkaline dihalides. Next, we will discuss the polarized nature of the carbon-halogen bond. The halogen atoms are more electronegative than the carbon atoms, so the carbon-halogen bond in alkyl halides is polarized in nature. The carbon has positive charge and the halogen atom are negatively charged. As we move down the group, the size of the halogen atom increases from fluorine to iodine. Fluorine is the smallest atom and iodine is the biggest. So, as a result, the carbon-halogen bond also keeps increasing. For example, the bond length of CH3F, that is the methanide fluorine bond, is 139 picometers and the bond length of CH3I, that is methanide iodine bond, is 214 picometers. Now, we are done with the nomenclature of the haloalkanes and haloarenes and have also done their classification. I will give you one question to think about and research. The question is, think of some haloalkanes and haloarenes used commonly in our daily routines. Search for this question and wait for the next video where we will further carry on the discussion on haloalkanes and haloarenes. Now, let us summarize what we have learnt.
Manorama Horizon. Learning made simple.